Hi, so in this video we are going to look at equation of a straight line, National 5 context questions. So context questions, as we know through maths, is when we put it into real life. So we're no longer going to see x and y axes, we're going to have things there like speed, distance, time, weight, age, all different things that are actually related to real life. So our lesson intention is to be able to find a formula connecting our two variables basically by applying the equation of a straight line method we've been shown. We're going to get our gradients, we're going to get our y-intercepts if we can, and we're going to plug them into the equation of a straight line, and then we're going to use that equation of a straight line to make some kind of prediction for our part B. So let's have a wee look then at this. So here we have a very basic diagram with a straight line on it. Now, this graph shows the linear relationship between the cost of hiring a bike and the number of hours you have the bike for. Now, common sense would tell us the longer you hire a bike, higher the cost, which is shown on the graph here. Now, the only information we're given is that 1 hour costs £8 and 6 hours costs £23. Now, I know there's no coordinates in a straight line, but they're actually given to us in the question. 1 hour would cost £8. So if you were to plot that, you would be going along to number 1, up, and then reading that across, and that would be 8. Oops, that's a funny looking 8. So there's your first coordinate. That gives us a coordinate of 1, 8. Plotting the second bit, you'd go along to 6 hours. You'd plot up and across, and that would cost 23. And I can't seem to get it in. So there's your second coordinate, 623. So you might at first glance think, oh, I don't have coordinates, but it's given to you in context this time. So let's have a look at this. Usual rules apply. We're going to go get the formula in terms of x and y, and then we're just going to change our x and y to c and h. So our gradient formula is subtracting your y coordinates, so that would be 23 take away 8 over 6 take away 1. 23 take away 8 is 15. 6 take away 1 is 5. So that gives us a gradient of 3 over 1, or just 3. So our gradient is 3, and that's quite a nice gradient. Now, we don't have a C value. We don't have any idea what it costs if you've not booked for any hours. Technically, that would be what our call out or what our deposit might have been. So we don't have a C value. So when we don't have a C value, you know, my preference is to go use y minus b equals m bracket x minus a. Choose one of those coordinates. Let's go with the first one with the smaller numbers. Replace them with a and b. So we're going to have y take away 8 equals 3 is our gradient and a is 1. We're going to expand that bracket. Y take away 8 equals 3x minus 3. And move that minus 8 over. Minus 8 becomes plus 8. So you've got minus 3 plus 8. Again, I know some of you are going to skip that wee line. Tidy that up. We have 3x. Negative 3 plus 8 is 5. And then we're going to go change these. Remember, our y-axis has got a c beside it, so y becomes c for cost. Our x-axis has an h, so that becomes an h for hours plus 5. So part A, our formula connecting the cost and the number of hours is done. Cost equals 3 times the number of hours plus 5. Now part B asks us to use that formula to work out how much it would cost to hire a bike for just 5 hours. So H is going to be replaced with 5 this time. So our cost would be 3 times 5 plus 5. So our cost is 15 plus 5. Our cost equals £20. And I've put my units in for that one because cost is in money. Now that is a typical National 5 exam paper question. Okay. Couple of things to point out again. Remember, if you don't know C, we use the more complicated formula. You, at the end, make sure you change your x and y. So at this stage here, it's very important to change your letters to match what's on your diagram. And then the wee substitution bit's only ever maybe worth 1 or 2 marks. And it's really not too bad, but that's the bit people miss out because I don't think they understand what it's asking. It's just substitution at the end of the day. Let's have a look at another one. So this question, if I recall, actually came from the 2019 National 5 exam. The fuel consumption of a group of cars is recorded. The scatter graph shows the relationship between the fuel consumption, F kilometres, and the engine size, E, in litres of the cars. We have drawn the line of best fit already. We can clearly see there's no C value, so I'm going to use the Y minus B formula again. They have drawn a line of best fit, and we have to find the equation of the line of best fit. So I'm just going to move this ever so slightly so I've got a wee bit more room to work with. We don't really need all that now anyway, because we know what it's asking us to do. So, step 1, we need to pull off coordinates, and this is the tricky bit. This is where, in my experience of marking, people don't choose the coordinates very well. Coordinates aren't necessarily always dots. It is somewhere clear where the line goes through on your grid, but however, we've been lucky in this one, look. And this is what they're starting to do, I think, because it makes it easier for us to mark. There is a clear dot on the line there, and there is another clear dot on the line down there. So we're going to use them as our coordinates. The difficulty, folks, is reading off those coordinates correctly. You go along. Now this one is right in the middle of 1 and 2, so our first coordinate is 1.514. Our second coordinate is between 3 and 4, so that would be 3.5 and up 8. Don't let those decimals put you off, okay? Because they're going to disappear in a minute, I think. Okay, gradient. Subtract your y's. So we have 8 take away 14 over 3.5 minus 1.5. 8 take away 14 is negative 6. So looking at the equation, look at the line. It's going down the way, so we know it's going to have a negative gradient, so that's okay. 3.5 take away 1.5 leaves us with 2. So really we just have minus 6 divided by 2. 3 over 1, just 3. So our gradient is minus 3. Again, remember we don't have a C value, so we're going to go use this one. The y minus b equals m bracket x minus a. Choose one of your coordinates. Let's go with the one with the easier numbers. We're going to relabel that a and b. So we have y minus 14 equals negative 3 for your gradient, x minus 1.5. Y minus 14 stays as is. We're going to expand that bracket by negative 3 times, and anything by negative 3 will reverse all your signs. So we have minus 3x, a negative times a negative turns into a plus. 3 times 1.5, if you can't do that easily mentally, 3 times £1.50 is £4.50, so 4.5. And then what we've still to do is move that minus 14 over, it will become plus 14. So we have y equals negative 3x plus 4.5 plus your 14 gives us negative 3x plus 18.5. Now the final thing to do here is, remember, it's not x's and y's. Y up here, your y-axis, has been replaced with f. So we have f equals negative 3. X is E for engine size, so negative 3E plus 18.5. So the equation of this line for the part A is F equals negative 3E plus 18.5. So that formula tells us the fuel consumption is negative 3 times your engine size, add on 18.5. Now the part B, if we look at the question, it says her car has an engine size of 1.1. We have to use our equation from part A to work out how many kilometres per litre she should expect to get. So I'm just rewriting out the equation we got in the first wee bit. Okay. Now they've told us our engine size is 1.1. So we're going to replace E with 1.1. So we have negative 3 times 1.1 plus 18.5, which is negative 3.3 plus 18.5. Now, if you're finding it difficult to go from minus 3.3 and add on 18.5, that is just the same as reading it the other way around. It's 18.5 take away 3.3. For some reason, that suddenly looks a lot easier. That gives us 15.2. So our fuel consumption is 15.2 kilometres per litre. Units wouldn't be important here though. You would get away with just writing 15.2 for this one. Alright, so that was a question in a previous exam, and what I found through people was this final calculation was putting in that 1.1 there. Okay, let's have a look at, again from an exam paper. We have the cost of a journey with Tom's taxi depends on the distance travelled. We know that, the longer you travel, the more your cost. The graph shows the cost pounds along with the distance, and they've marked on A and B. It says point A represents 8 miles, which costs 14, so that would be along A up 14. And point B represents a 12-mile journey, which costs £20. So the coordinates we're going to use here are 8:14 and 12:20. So again, the coordinates aren't on the picture this time, but they are in the story. We are going to go as usual. We want the equation at line. There's no nice C value again, so it's going to be the y minus b one, folks. So our gradient is 20, take away 14, subtracting the y's. Then subtracting the x's is 12, take away 8, which gives us 6 over 4 and 3 over 2 this time. You could, if you want, use that as 1.5. However, I like to keep it as fractions. So our gradient is 1.5. And I need to go get the equation aligned, so please forgive me while I just move this out the road, because I don't have enough space here. So I'm going to just move this over a wee bit. We're going to choose one of the coordinates and we're going to make that A and B. So I'm going to use the first one because it's got lower numbers, and that's going to be my A and my B. So we have y minus b equals m bracket x minus a. So we have y minus 14 equals 3 over 2 bracket x minus 8. Now you have an option here. We could multiply the whole left hand side by 2, or we could multiply the bracket out by 3 over 2. Are you confident at doing 3 over 2 times 8? Let's have a wee look. So y minus 14 equals 3 over 2x minus, and remember 3 over 2 times 8, if we go back to first year, good old divide by the bottom times by the top. 8 divided by 2 is 4, 4 times 3 is 12. So it gives us that. And that maybe saves us a wee step then. I would only make you do it that way if it was a number where the fraction could multiply by it nicely. Okay? Had there been a 3 in the denominator there, 3 doesn't go into 8, so I would never get you to do it that way. Okay, move the 14 over, it becomes a plus 14, so we have 3 over 2 x minus 12 plus 14. So y equals 3 over 2x plus 2. Now, we didn't have it in terms of y and x, did we? I need to go back and look at what that question had. So in terms of x's, our y-axis was p for price, and our x-axis was d for distance. So our price equals 3 over 2 times our distance plus 2. That is our part A. That is our formula. Okay. And now we're going to look at what part B says. Okay, so the part B to this question asks us to use your answer to part A to calculate the cost of a 5-mile journey. So our formula for part A was our price was 3 over 2 times our distance plus 2. Okay, so our distance in this case is going to be replaced with the number 5. So our price is 3 over 2 times 5 plus 2. Now 3 over 2 times 5, if it helps, you could think of that as 1.5 times 5. Or you could do 3 over 2 times 5. Good old divide by the bottom, times by the top, leaves us with £2.50 times 3, which is 7.5 plus 2. So our price here would have been 9.5. Now the year this was in the exam, this was worth 1 mark, and the people who left their answer as 9.5 didn't get that 1 mark, sadly. We were looking for the cost of a taxi journey. You would never say the cost of this taxi journey is 9.5. You would say the price is £9.50. So you must turn it into money. You must add the pound sign and you must add the 0, because we are in context. The minute a question is in context, we need to include our units. Okay, it's that video. Hopefully you followed that okay, and with a bit of practice, if you look at all the other National 5 past paper questions, they're very much like the two I've just shown you. Get your gradient, get your equation of a straight line, change the letters to match the picture, do a wee bit of substitution in your part B. The one thing is I would point out is you have to use your correct letters. Don't be the fool that loses 1 mark for not doing that. Okay, take care and good luck. And that concludes